Hi friends, I am Richa and today we are going to go over a tutorial on Apache Lucene as a search engine. So I have created a Java project with 5 Java classes. So my first class is Lucene constants.java, which has type of searches to be performed and the maximum search that is set to 10, that is the top results to be returned. Then there is a text file filter to go over the extension of the files. So this is going to filter out any other files which has any other extension other than .txt in our input data directory, and then we are going to create an indexer over the list of the files, and then we are going to go create a searcher and then execute our code. So I go over the code for indexer.java. So there is a class level variable index writer which will be used to write the indexes in the data directory. This is the constructor to create the indexer object which is taking index directory path. So this is the path where the indexes will be created, and then we are instantiating the variable index writer by passing the directory path and a standard analyzer which goes over the stop words which are there in the English dictionary with version as Lucene_36. I have a private method called getDocument which is going to get the file and then create indexes based on content field, file name field and file path field by passing either contents, file name or file path. So these are the keys, these are the values, and then we're going to store it yes, and then field.index is one of the enum values which is set to not underscore analyzed, means this is not going to go under the analyzer, it is just going to get stored as string. So we add these fields to the document and then return the document. Index file is basically the point where we are indexing and we are writing it to the indexer. Create index is the entry point. We can see that it is a public method, is the entry point for indexer.java, which checks whether the file is belonging to a directory, whether it exists or not, is not hidden, and then the extension here which is there in text file filter.java, this method, and then we are indexing. So we go here, index file, the file comes here, and we go to get document, do the indexing, returns the document and writes the document. So this is the index part of it, and we are closing any of the resources that we created or used in our indexer.java. So then now I have created a Java class called searcher.java which is taking an index searcher, a query parser and the query to create the query and run. This is the constructor. We are initializing it with the index directory path which contains the list of like all the indexes that were created on the list of files. So we are creating an index searcher object, initializing this, and then creating a query parser which is taking the same version that was used, same version of Lucene that was used for creating the indexes, and then the type of query searching we want, so we are setting it to contents, and then passing the same analyzer to the query so that it removes the stop words in the similar way that the indexer used. So that's how we have initialized a searcher object. And then there is the method called search. So this is going to perform the basic search by creating a query using the query parser and passing the maximum search results. So top 10 results would be returned when this method is called in form of top docs, which will contain the list of matched documents. And then there is a get document method. We'll go over this method later on in the tutorial, and again a close method to close the resources. So I have a main method Java class that is called Lucene tester, where I am initializing the index directory, that is where the indexes will be created, the data directory which has a list of input data. So I'll just go over and quickly check my data folder which has around 10 txt files which has student data like this and the name. This is the main method. So we have created two private methods here just to segregate the indexing part and the search part. So we instantiated a tester object, and then first we are calling the create index. We have to make sure that first we create the indexes over the documents and then only we search. So we go here to create index. So again for index we are going to utilize the indexer.java. So we have instantiated it via the constructor we created. This is nothing but we are just trying to record the timing that is being taken by the program to index the 10 documents. So we are passing the filter, the data directory, and then creating the index. So this will go here and we'll go over the code that I showed before, and this is recording the end time of indexing and then printing the milliseconds. after closing the indexer. So after the index has been created, the next step is to search. So this is our query Mohan. So this is what we are going to look in the documents. Go to the search method, which is again a private method, which is taking the input as the index directory, because there it is going to go and search on the indexed data. So searcher we have created, and then we do a searcher.search, which is returning the top tech docs which we saw, which is there in the searcher.java, which is taking the search query which is parsed and then searched. So after we get the results, we print this code, so which I am going to go after running the document, the program. So I have put a breakpoint here, and I am going to explain this code one by one. So I just right click and debug as Java application. So we see that our program has gone over the 10 record documents here and performed the indexing. So 10 files have been indexed, and the time taken was 72 milliseconds. And then we have the breakpoint here. So it is there in the search method. So after the search, so how are we going to perform the search? So it is going, after it has initialized the search object, it is going in the searcher. So I'll just press F6 to go in to get the results. So this is the results, that is called hits. So I'm just go over it and inspect to see the results. So total hits is the number of documents that matched. That is, the maximum score is the highest matched document score, that is 0.9. So in this case, it is only, we have only one document, and then these are the score docs, which will have like list of documents that were matched. So we can see that doc is equal to 4, that is the fourth document, which has score as 0.9. So the score is nothing but it is a value returned between 0 to 1, the closest match being closer to 1. So we see that it has highly matched. So now I am going to iterate over this hits to identify which documents were returned as a result. So I do an F6 recording the time, and this is my for loop to go over the document, and then this is returning the information related to the document in the results, and then we do a doc get and print the file path. So in this case we have only one matched file, we might get more files matched. So this is the file, it says that it has matched with score 0.9 as we saw. So we are expecting to find Mohan in record4.txt. I'll just come out of the program by pressing F8 and we go to record4.txt. And see that we have matched the document correctly and we have found Mohan here. I'm just going to go over the index directory to see how the indexes were created. So these are the metadata related to the indexes that were performed. So we successfully ran our program. Thanks for watching.